Consider the statement, "This sentence is false." If it's true, then it must be false. But if it's false, then it must be true. This isn't just a word game, it's a crack in the foundation of logic. This type of self-referential statement creates a paradox, a loop from which truth cannot escape. Your mind trying to solve it feels like a hamster on a wheel, running faster but going nowhere. What happens in our brains when we encounter these impossible loops? In 1931, a logician named Kurt Gödel formalized this problem. He created a mathematical statement that essentially said, "This statement cannot be proven. If you prove it, it becomes false. If you can't prove it, it's true but unprovable within the system." This revealed something staggering. Any logical system, like mathematics, will always contain true statements that it cannot prove. There will always be truths beyond our reach, not because we aren't smart enough, but because the system itself forbids it. This self-reference isn't just about logic, it's everywhere. Have you ever stood between two mirrors and seen an infinite tunnel of your own reflection? That's a physical form of recursion. Each reflection contains a smaller reflection, which contains a smaller one, forever. This pattern, where a thing is defined in terms of itself, is called the Droste effect, named after a Dutch brand of cocoa that used it on its packaging. It's a window into infinity, found in an ordinary box. Nature uses this trick constantly. A fern frond is a perfect example. The entire frond has a specific shape, and each smaller leaflet on that frond is a miniature version of the whole thing. A Romanesco broccoli grows in a perfect spiral, but each smaller floret on that spiral is itself a smaller, identical spiral. These are fractal patterns that repeat at every scale. Nature builds immense complexity from one simple, recursive rule. We even build recursion into our questions. What happens when an unstoppable force meets an immovable object? The question itself is a paradox built on faulty premises. If an unstoppable force exists, then by definition, an immovable object cannot, and vice versa. The question collapses under its own internal contradiction. It's not a question about physics, it's a question about the limits of concepts. It's a self-answering question where the answer is, the question itself is impossible. This matters because the questions we ask science determine the answers we get. For decades, physicists debated what happens to information that falls into a black hole. Does it vanish, violating the laws of quantum mechanics? Or does it escape, violating the laws of general relativity? This was another unstoppable force versus immovable object scenario. The paradox forced scientists to seek a new framework, like the holographic principle, that could unify these conflicting ideas. The impossible question revealed the boundaries of our knowledge. Perhaps the most profound recursion happens right inside your head. You are thinking right now, but you can also think about the fact that you are thinking. This is metacognition. It's a self-referential loop. The thinker and the thought are part of the same system, observing itself. Douglas Hofstadter called this a strange loop, a tangled hierarchy where by moving up or down through levels of a system, you unexpectedly find yourself back where you started. He argued that our very sense of I, our consciousness, is a strange loop. This looping structure has very real consequences. In computing, Alan Turing asked a simple-sounding question. Can you write a program that can determine if any other program will finish running or get stuck in an infinite loop? This is called the halting problem. Turing proved it was impossible by using self-reference. He imagined a program that would do the opposite of what the theoretical loop detector predicted, creating a paradox. This single, self-answering question established the fundamental limits of what computers can ever know. Turing's exploration didn't stop there. He then posed another question: can machines think? This question is different. It doesn't have a simple logical answer. It's a self-answering question for humanity itself. To answer it, he proposed the imitation game, or the Turing test. A machine is thinking if we can't tell it apart from a human. The question isn't about the machine's internal state, it's about our perception of it. We answer the question by creating the very thing we are asking about. The entire field of artificial intelligence is the ongoing process of answering this one question. From a sentence that eats itself to the code that defines our digital world, self-reference is not a bug, it's a feature of reality. The questions that loop back on themselves, the ones that seem paradoxical, are often the most powerful. They don't just ask for an answer from the world, they challenge the very framework of the question itself. What is outside the universe is a question that forces us to define outside and universe. The inquiry reshapes our concepts. The truth generated isn't a simple fact, but a deeper understanding of the question's own limits.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.